Let me walk you through the entire architecture from top to bottom. At the top, we have the user accessing the application through a web browser. The user connects to a CloudFront distribution, which is a CDN that serves the front end fast and globally. CloudFront is configured with an Origin Access Control, or OAC, which means it's the only way to access the S3 bucket. The bucket itself is completely private. All public access is blocked. This is a security best practice. Never expose S3 directly to the internet. Inside the S3 bucket, we have static assets, index.html, callback.html, CSS files, and JavaScript modules for authentication, API calls, and UI logic. When the user first loads the app, they're directed to Cognito's hosted UI. This is managed by AWS, so we don't build a login form ourselves. The user signs up with an email and password. Cognito sends a confirmation code to their email. They verify it. Then they can log in. After login, Cognito returns an ID token, a JWT, that proves who the user is. This ID token is critical. It's passed with every API request and validated by AWS API Gateway before Lambda ever runs. The front end makes HTTPS requests to the API Gateway, HTTP API endpoint. This is our API layer, the gateway between the front end and our business logic. Before invoking Lambda, API Gateway runs a Cognito JWT authorizer. This authorizer checks, is this token actually from our Cognito user pool? Does the audience, the odd claim, match our SPA app client ID? Is this token still valid, not expired? If any of those checks fail, API Gateway returns 401 or 403, and Lambda never runs. This is the first line of defense. If the token is valid, API Gateway invokes the Lambda function. This is a single Node.js 18 function called serverless-to-do-app-router that handles all the CRUD routes. The function receives the user's ID from the JWT claims, specifically the subclaim, and uses that to ensure they can only see and modify their own tasks. Inside the function, we have four main routes: post/tasks, create a new task with a description and mark it incomplete; get/tasks, list all tasks for the logged in user; put/tasks, update a task's description or completion status; delete/tasks, remove a task. All of these operations hit DynamoDB. The DynamoDB table is called to-do-task and has two key fields. Partition key user ID. This groups all the user's tasks together. Sort key task ID. This uniquely identifies each task. DynamoDB is set to on-demand billing, so we pay only for what we use. There's no capacity planning or scaling configuration needed. Here's the critical part. Because every DynamoDB query is filtered by user ID from the JWT, a user can never access another user's tasks. Even if they try to guess a task ID, the security is baked into the code. So the full flow is, user logs in through Cognito hosted UI, receives an ID token. Front end sends JWT with each API request. API Gateway validates the token with the Cognito JWT authorizer. Lambda extracts the user ID from the JWT claims. Lambda queries the DynamoDB using the user ID to list, create, update, or delete tasks. Response is returned to the front end and the UI is updated. All of this is serverless. No servers to provision, no patching, no scaling knobs to turn. AWS handles all that.